Generator connection accessories. Current transformers. Current transformers are installed in the generator connections for metering, protection, and control. The specifications for the current transformers, their assigned location, and sequence in generator connection are finalized by the project authorities based on system parameters, protection philosophy, layout, and relay characteristics. A typical line diagram incorporating current transformers in the generator connection of a large unit, comprising a generator, generator circuit breaker, generator transformer, and unit auxiliary transformers, is detailed. Tap-off connections to excitation transformer cubicle, surge protection and voltage transformer cubicles, and earthing cubicles are not shown since they do not incorporate current transformers and are included in the zone of protection of main equipment. These current transformers can be either installed in the run of the isolated phase bus or integrated with any of the major equipment. They can be installed on the phase and neutral bushings of the generator, as an oil-immersed bushing-mounted transformer inside the tank of generator transformers and auxiliary transformers, and on either side of the generator circuit breaker by the respective equipment manufacturer. The differences in the design parameters of a current transformer for generator connections and other applications in medium voltage distribution are: extremely large conductor and enclosure diameters of the main and delta bus. Very high rated primary current for current transformer installed in main and delta bus. Very high short circuit current, especially for the tap-off bus. Very high ratio of short circuit current to rated current in tap-off bus. The specific requirements of the generator connection, coupled with the physical dimensions of the conductor and enclosure of the connection, make the design of the current transformer unique. All current transformers in the run of the isolated phase bus are bar primary, ring type. This is primarily dictated by size of the conductor and very high fault current. Current transformers installed in the isolated phase bus are clamped to the enclosure in 4 locations along the circumference. These are essentially low-voltage current transformers, with the major insulation being provided by the air column between the inner surface of the current transformer and the outer surface of the conductor. The diameter of the current transformer is large. Current transformers installed on insulated generator bushings are also low-voltage rated and much smaller in diameters. Current transformers installed inside the tank of a generator transformer or unit auxiliary transformers are also low voltage rated, oil immersed, and insulation is provided by the porcelain bushing. They are subjected to much better cooling and the diameters are small. Current transformers installed inside the generator circuit breaker will have air as the primary insulation and will have dimensions dictated by the diameter of the enclosure and conductor of the generator circuit breaker. The diameters of the current transformers will be large. Current transformers installed in the tap-off bus may have to be designed for the rated voltage if the available air clearance is not adequate to meet the basic insulation level. A conducting aluminium foil, integrally cast along the inner diameter of the current transformer, and acting as an equipotential surface, is connected to the tap-off conductor to eliminate partial discharge. Current transformers located in different areas of connections may have different physical dimensions, and consequently they will have different mean magnetic path. The current transformation ratio of the current transformer installed in main, delta, and tap-off connections will be different. The short circuit withstand current rating of the current transformers will be different in main, delta, and tap-off connections. The turns ratio of the current transformer will be different for main, delta, and tap-off connections. The core cross-section area of current transformers located in main and delta connection will be small and those in tap-off connection will be large. It is a challenge to meet the specified instrument security factor for current transformer in the main bus. Many manufacturers recommend voltage-dependent resistance across the current transformer to meet the requirements. Similarly, it can be a challenge to meet the specified burden with the desired accuracy class for current transformer in tap-off bus. The magnetizing current for different mean magnetic paths with varying cross-sections will not be identical. This needs to be considered for differential relay inputs. Current transformers can be assigned a standard secondary current rating of 1 ampere or 3 amperes or 5 amperes. The selection will depend upon the system parameters, type of device connected to the secondary, lead resistance, and constraints expressed by equipment manufacturers to accommodate them on the generator terminal bushings or inside the tank on transformer terminal bushings. Current transformers are static, passive devices and therefore, if they are well specified, designed, manufactured, and installed, will require no maintenance for the life of the component. It is advisable to cast each core separately. Since the fault levels are very high in a generator connection, a severe fault current with a high DC component can permanently magnetize the core. This is referred to as remnant magnetization or residual magnetism. Its effect is to shift the bias along the BH curve. The phenomena could lead to significant variation in the magnetic parameters that were assigned at the time of manufacture. These variations are observed when testing a current transformer for its short circuit withstand capability. Demagnetization could be a very complicated process. To overcome permanent magnetization, many suggestions, such as having a calibrated air gap in the magnetic circuit or installing a Rogowski coil, have been made. These are beyond the scope of the present discussions. Under ideal conditions for a current transformer, the secondary current waveform will be purely sinusoidal, when the primary current waveform is sinusoidal. This is true when the current transformer operates symmetrically in the linear region of the BH curve. Should the primary current drive the core of the current transformer to saturation, the secondary current will get distorted. The distortion will be more pronounced when the degree of saturation is high. A three-phase fault at the generator connection generates a highly asymmetrical short-circuit current waveform with a significant DC component. The effect of the DC component will be to shift the bias along the BH curve, resulting in an asymmetrical distorted secondary current waveform. For a comprehensive understanding of the theory and practices of busbar systems, it is advisable to read the book An Introduction to Busbar Systems, where contents are organized in a sequence for ease of reading and facilitates cross-reference. Please procure a copy of the book with a requisition to Bala at busbarsystems.net.